All right, we're going to practice solving systems of equations through substitution. Now, first, let's talk a little bit about what a system of equations is. So, a system of equations is several different equations that are what we call simultaneous, meaning whenever I say x here and whenever I say x here, I'm talking about the same value. So, whatever is here will also be here. Whatever is here for my y will also be there. So, I've got this system of equations. These equations go together. And to find the solution, I need to find an xy pair that will make both of these statements true. All right? But here's the problem. If you look at this first equation, I have two variables. So if I isolate my x, I still don't know what y is. If I isolate y, I still don't know what x is. So that's going to make things very difficult. So all of these methods that I'm going to teach you, what they do is they basically get rid of one of the variables. And by getting rid of one of the variables, we wind up with something that we can solve. So the substitution method, what it does is it takes one of our variables and it isolates it. Now, in this case, this x is already isolated, so I can say that x equals this. Now, what I do once that happens is I make a substitution. I say, oh, well, I know that x equals this, so I can take this right here and replace it with whatever x equals. So 4 plus 3y. And something magical has happened now. Instead of having two variables, now I only have one variable. So this turns into something that you can solve. So we get 8 plus 6y plus 3y equals 7. 8 plus 9y equals 7. 9y equals -1. And y equals -1/9. All right, so we have half of our solution. Well, what am I still missing? I'm missing my x. So the way that you find your missing value is you take your y and you substitute it back in for one of these. Now, I prefer to do it for this one because it's already solved for x. So x equals 4 plus 3 times -1/9. So x equals 11/3. So what is my solution? What's going to make both of these true? An x of 11/3 and a y of -1/9. All right. Let's take a look at this one. Now, this is one that we could probably solve easier through elimination, but let's practice doing it with substitution just so we understand the process. So in order to do this, I need to isolate one of my variables. It can be x, it can be y, it doesn't matter. So let's go ahead and isolate the y just to show that it doesn't matter. So instead of y, I'm going to write 10 minus x. So let's see, x minus 10 plus x. 2x minus 10 equals 5. X equals, what is that? That is 7.5. All right. So now I have half of my solution. I just have to take that, plug it back in somewhere. I could plug it in here or here, but it's actually a little easier if I plug it in to this modified version over here. And since this one's easy to check, let's just check this real quick. 7.5 plus 2.5 equals 10. That's correct. 7.5 minus 2.5 equals 5. That is also correct. So that is my solution to the system of equations. Now, I'm going to show you some other ways of doing it. It doesn't really matter which way you solve it, but this method is probably the easiest one when you already have a variable that's isolated. That's when substitution really is probably the easiest way to go about it.